An ester is an organic compound characterized by the presence of a carbonyl group, which is composed of a carbon double bonded to an oxygen atom. This is the general formula of an ester. As you can see highlighted in the green, there's the carbonyl group, which is bonded to an oxygen atom. This is the definition of an ester. An example of naming an ester. Here we have methanol and butanoic acid. We take the alkyl group from the alcohol, take the prefix and add YL, turning our methanol into methyl. For the butanoic acid, we take the prefix of the acid and change the OIC acid ending to OATE, giving us butanoate. So our ester is then methylbutanoate. An additional example is ethanol and ethanoic acid become ethyl ethanoate.
Now looking at the intermolecular forces, esters are polar molecules, meaning they have dipole-dipole forces. However, their dipole-dipole forces are smaller than those of their parent acids because of the replacement of the polar OH. As you can see below, acid contains the functional group OH, whereas ester does not. Examining solubility, esters are soluble in water, however, they are less soluble than their parent acids because of their decrease in polarity and dipole-dipole forces. As we look at melting and boiling points, esters have lower melting and boiling points than their parent acids because of their smaller dipole-dipole forces. Small esters have boiling points which are similar to those of aldehydes and ketones. Smaller molecules have smaller London forces and therefore lower boiling points. Larger esters have higher melting and boiling points.
Reactions which form esters. Esters are organic salts formed from the reaction of a carboxylic acid and an alcohol. In this reaction, known as esterification, the alcohol acts as an organic base, and the ester formed may be considered an organic salt. Heat and an acid catalyst are generally required for the reaction to occur. The acid contributes the OH group to form the water molecule, as shown in our diagram below. A sample reaction that forms an ester is ethyl butanoate, which has a banana scent. The butanoic acid and the ethanol alcohol come together to form ethyl butanoate ester. The OH from the acid and the H from the alcohol come together to form the water. Reactions that use these molecules. Fats and oils are esters of long-chain acids. When they are heated with a strong base like NaOH, a hydrolysis reaction occurs. A hydrolysis reaction is a reaction in which a bond is broken by the addition of the components of water, with the formation of two or more products. In this reaction, the sodium salts of the acid that result are what we call soap. This reaction is called saponification. As you can see in our example, the ester reacts with the NaOH to produce the sodium salt of an acid and alcohol.
This example of hydrolysis combines methylbutonate, an ester, and sodium hydroxide, a strong base, to form butanoic acid and methanol. Also, when certain reactants are used, esters can be formed repeatedly and joined together to form long chains. These large molecules are called polymers.
Fun facts!
Small esters are detected by their scent because they are gases at room temperature. Methylbutonate has a scent of apple, pentylbutonate has a scent of apricot, 3-methylbutyl ethanoate has a scent of banana, and ethyl benzoate has a scent of cherry.